This tutorial will start backwards. I will first run the pre-built simple genetic algorithm Python application, and second I will use the output from running this simple application in order to quickly explain various genetic algorithm concepts, and third I will step by step build the application using a PyCharm IDE. This is a pre-built Python application, so if I go ahead and run it, we go from generation 0 to generation 6, and if we run it again we get a completely different outcome. Actually we get the same number of generations. Here we go, so now we got 4 generations, and each one of those is a chromosome, and here we have a population of chromosomes, and a chromosome is a potential solution, and here in each generation I am sorting the chromosomes by fitness. So for example here this chromosome has a fitness of 8, and it is the highest fitness in this population. And what fitness means here is how many genes are the same as the ones that are in the target chromosome. So here we have 8 genes that are the same as here, and each one of those is a gene, and we evolve from one generation to the next by doing selection, crossover, mutation, and elitism, and I will be going over those while writing the code. So this genetic algorithm ends when one of those chromosomes reaches a fitness of 10, since we have 10 genes. So all of those are the same as all of those genes. I will start by creating a new project. And here I will create a new Python file. This would be for genetic algorithm project 01. And here we will have 3 classes. A chromosome class, which represents a candidate solution, and a population class, which represents a population of candidate solutions, and a genetic algorithm class where the selection, crossover, mutation, and elitism logic will be. Now let me define this constructor in the chromosome class, and a position in this chromosome will be called a gene. So we will have an array representing those genes, and I will define this fitness representing the fitness of this chromosome, and for the purpose of this tutorial, I will have a population of 8 chromosomes, and let me define this target chromosome representing the solution, and I will have this while loop. So let me do an import of random. So the number of genes in this genes array will be the same as the ones that are in the target chromosomes, and I will randomly populate this array, so either 1 or zeros. And I need a get method for the genes and for the fitness. Now in get fitness, I will initialize the fitness to 0, and then do a for loop on all genes in the genes array, and I will add 1 to the fitness if the gene is the same as the one in the target chromosome. And I need a method that returns a string representation of this class. So this is like the toString method in Java. And what I'm returning here is the contents of the genes array. So this should do it for this class. Now going to the population class, I will have this constructor that takes in the size of this population of chromosomes, and we will use that size to instantiate new chromosomes and put them in this array. So I will have a while loop, and instantiate new chromosomes and put them in the array. And I need a get method that would return this private chromosomes array. And this will do it for this class. Now, before writing the code for the genetic algorithm, let me instantiate a new population given the population size, and I will sort that population by fitness, and the chromosome with the highest fitness will be first, and let me define this print population function. So here we have a for loop going through all the chromosomes in the past n population and printing them. And let me call this method from here with a generation of 0. So let me test run it before writing the rest of the code. Here we go, have a generation 0, and 8 chromosomes. This one has the highest fitness. Now going to the genetic algorithm class, I need a static public evolve method that will end up calling two private methods, a crossover population method, and we pass it this population, and what's returned from that we call mutate population on it, and both of those are also static. So let's go ahead and define those two methods. So for now, let's have this crossover population return the past end population, and I will have the mutate population method do the same thing. So now if I run it, it will go forever. Actually, let's have the code that goes over and evolve the chromosomes from one generation to the next. So I'll have a while loop, and here we had generation 0. So the while loop will start from generation 1. So while the fitness of the fittest chromosome in each population is smaller than the target chromosome length, so in this case that will be 10, since we have 10 genes in this target chromosome. So we evolve the population and then sort that evolved population and print it, and then go to the next generation. So now let's go ahead and test run it, and it will go forever. Now going to crossover population, let's define this crossover population that we will be populating and returning. And let's go up here and define the number of elite chromosomes, and those chromosomes will not be subjected to crossover or mutation from one generation to the next. So now going back to the crossover population method, we will move those elite chromosomes as is to the new population, and the crossover population will end up calling this crossover chromosome method for each chromosome in the population, And this method does a random gene selection from each one of the parent chromosomes. So let's define this crossover chromosome that we will be populating and returning. And mutate population will end up calling this mutate chromosome method for each chromosome in the population. And since we will be using tournament selection, let's define this select tournament population method. And in tournament selection, a number of chromosomes are selected randomly, and from those, the one with the highest fitness is chosen. So if we go back up here and let's define this constant, the tournament population selection size. Now going back to the crossover population method, we will have a while loop that starts from 1 in order to exclude the elite chromosomes, and we will select 2 chromosome populations and pick the fittest chromosome in each one of those populations, and then we will call crossover chromosomes on those 2 chromosomes and append the returned chromosome to the crossover population. And let's increase the counter. So this should do it for this crossover population method. Next, let's go up here and define the mutation rate. And this is the probability that a chromosome gene will do random mutation, and the range is between 0 and 1, and it is usually small. So it should be smaller than this, but for the purpose of this tutorial, I used this number. So now if we go to the mutate population method, I will exclude the elite chromosomes. So I will start from 1, and here we are calling the mutate chromosome method for each chromosome in the population. So we do a for loop for each gene in the passed in chromosome, and if a random number is smaller than the mutation rate, then we perform mutation. So we set the gene randomly to 1 or 0 depending on if a random number is smaller than 0.5 or not. And in crossover chromosomes, the code that will do the random gene selection is this. and we still have to code one last method, the select tournament population. So we'll define this tournament population and return it. But before doing that, the code that will pick up a number of chromosomes randomly from the passed in population is this. So here we end up returning a population of 4 chromosomes. But before returning that population, we sort it by fitness, and the one with the highest fitness will be on top. Finally, let's go ahead and test run the application. So we went from generation 0, where the fittest chromosome was this one, to generation 8, and if we run it again, we go after 4 generations, we find the target chromosome.